Hi guys! Welcome back to another math video. Today we're learning something special.
Ooh, what is it?
We are learning about integers and the coordinate plane. We are retracing our minds back to positive and negative numbers and 0. We're tracing back to integers. Yes, we're tracing back to all those nice and lovely numbers. Remember when we did absolute value? The absolute value of a number is the positive distance that it is away from 0. Never negative. However, we are also going to be learning about the coordinate plane.
What is the coordinate plane?
That's a good question, Squeak. The coordinate plane is a graph that is formed by two perpendicular number lines that intersect at the origin, which is 0, 0. So this looks like a graph, and it probably is a graph because it has small squares on it, but besides that, you can also plot points. This leads to the reason why it's probably a graph, because you can graph things on it, like points. But these points aren't just any ordinary points. They're called ordered pairs, because they belong in a specific location on the coordinate plane, and those locations are called coordinates. Coordinates are overall locations of where the ordered pairs belong. So let's look at ordered pair A. This one is 2, -4. So it is 2 to the right of 0 and 4 down to 0. You want to know why? Because 2 on the x-axis, which is the horizontal line, is farther away from 0. So that would be 2 units to the right of 0. But then -4 is 4 down from 0. So that ordered pair A, would be 2 points to the right of 0 and 4 points down to 0. Because 2 is a positive number and -4 is negative. So yes, that is exactly what we're going to. 2 units to the right and 4 units down. That's where ordered pair A is. And ordered pairs can be in any location on the coordinate plane. They can even rest right on the lines. Like this one, ordered pair E, which is 0, 4. You want to know why? Because E is 0 points away from 0, but 4 above 0. This is why it is 0, 4. Because it doesn't go to the left or right, it just stays in the middle, but it does go up. So 0, 4. That's why only the y-coordinate has a number that is greater than 0. Because the x-coordinate is 0, which means it can't go left or right, it has to stay in the middle. But it's 4 above 0, so 4 would be the y-coordinate. The y-coordinate is the second number on an ordered pair, and the x-coordinate is the first. The y-axis, on the other hand, is the vertical number line of the coordinate plane, unlike the x-axis, which is the horizontal number line. And these 4 large squares on the coordinate plane are known as specific regions, scientifically called quadrants, or mathematically. But either way, mathematics is in science. And these quadrants are all unique on the coordinate plane because pretty much all of them contain ordered pairs. Let's look at quadrant 1. There are 4 quadrants on the coordinate plane, and quadrant 1 is the easiest to identify because over here we see that there are numbers to the right and above 0. So this is where quadrant 1 belongs in. So in other words, any ordered pair that belongs in quadrant 1 should have both of their x and y coordinates positive numbers. If not, it does not belong in quadrant 1. So for example, the ordered pair 4, 2 belongs in quadrant 1 because 4 is positive and so is 2. But the ordered pair 4, -2 does not belong on quadrant 1 because -2 is negative. So on quadrant 1, the ordered pairs need to be completely positive. If they're not, then they do not belong on quadrant 1. So quadrant 1, let's take a closer look at this. Quadrant 1 would be plus plus. Plus also means positive, rather than the addition sign. It could be the addition sign, but plus also means positive for numbers that are greater than 0. So, we can use this to identify any ordered pair on quadrant 1. So, let's give out another example. 8, 1 also belongs on quadrant 1 because 8 is positive and 1 is positive. But 8, negative 1 is not in quadrant 1 because negative 1 is negative. So, both of the x and y coordinates of any ordered pair that belongs in quadrant 1 have to be positive, or else it is not a quadrant 1 ordered pair. Quadrant 2, however, is the complete opposite because it faces the left this time. So in quadrant 2, ordered pairs need to have their x coordinates negative, but y coordinates positive. So for example, the ordered pair negative 6, 4 belongs in quadrant 2 because negative 6 is negative and 4 is positive. So negative numbers first and positive numbers last is in quadrant 2. But quadrant 1 has both positives. And quadrant 3 is kind of special. Quadrant 3 is the true opposite of quadrant 1 if we are talking about the overall signs. If we are talking about which direction, left or right, quadrant 2 would be the opposite. But quadrant 3 is the true opposite because quadrant 1 is plus plus, but quadrant 3 is minus minus. They're both minus. This means that any ordered pair that belongs in quadrant 3 needs to have their x-coordinate negative and their y-coordinate negative. So both of their x and y coordinates have to be negative, or else it doesn't belong in quadrant 3. So for example, the ordered pair negative 4, negative 7 belongs in quadrant 3 because negative 4 and negative 7 are both negative numbers. And quadrant 4 is one of the most unique and probably the least known ones because it is not taught as often as the other 3. Quadrant 4 is kind of special because it is the opposite of quadrant 2, which is minus plus. But quadrant 4 is plus minus, so the signs are flipped around. In quadrant 4, on the other hand, as opposed to quadrant 2, any ordered pair that belongs in quadrant 4 should have their x-coordinates positive, but their y-coordinates negative. This makes quadrant 4 one of the most special ones, because that is the last quadrant. And if we go up again, we start back in quadrant 1. There are no more quadrants. And they are called quadrants because quadrant has the word quad in it, which means 4. And there are 4 quadrants. Quad means 4, so 4 of those 4 spaces would make sense. A 5th quadrant would not make sense because 5 is not 4. Duh. Quad means 4, not 5. That's quint or pent. So, these are the quadrants of the coordinate plane. So let's review. Any ordered pair that belongs in quadrant 1 should have both of their x and y coordinates positive. Any ordered pair that belongs in quadrant 2 should have their x coordinate negative but their y coordinate positive. And any ordered pair that belongs in quadrant 3 should have both of their x and y coordinates negative. And any ordered pair that belongs in quadrant 4 should have their x-coordinate positive and their y-coordinate negative. So you see, quadrant 1, both have to be positive. Quadrant 2, negative and then positive. Quadrant 3, both negative. And quadrant 4, positive and then negative. So quadrants 2 and 4 are pretty much the most difficult ones because both of them are not pluses or minuses. One of them is minus and one of them is plus. But they're both used in the opposite way. So quadrants 2 and 4 are the most difficult. But quadrants 1 and 3 are the easiest. Specifically, quadrant 1's the easiest because it has both the x and y coordinates positive. Quadrant 3 is also easy because it has both of them negative. But quadrants 2 and 4 are the hardest to interpret because Quadrant 2 has the x-coordinate negative but y-coordinate positive, but quadrant 4 has x-coordinate positive but y-coordinate negative, which can really twist the signs around. So quadrants 2 and 4, the hardest ones. I would recommend just trying a few of these practice problems, because they can be very hard to master. Quadrants 1 and 3, however, you can experiment as much as you like. These are the easiest to remember, because they both have plus and minus, whereas quadrants 2 and 4 have only a specific positive or negative rotation. See, look, negative plus, plus, minus. So you see, it swaps the signs around. So now that we know all the quadrants, we can plot any ordered pair on the coordinate plane. But did you know that there are ordered pairs that do not belong on any quadrant at all? Let's look at some of these ordered pairs. Do you see the x and the y lines? Well, mentioned earlier, this is the x-axis, or the horizontal line, and the y-axis is the vertical line. Now, ordered pairs have two numbers on them, called coordinates. The first number of this ordered pair is the x-coordinate, the second number, the y-coordinate. But did you know that there are ordered pairs that do not belong on any quadrant? Well, this is because there are some ordered pairs where their x-coordinate or y-coordinate is 0, which is not positive or negative. However, quadrants 1, 2, 3, and 4 all use either the plus or minus signs. So, but 0 is not positive or negative, so it doesn't use plus or minus, so it doesn't belong on any quadrant. So, for example, the ordered pair 0, 10 does not belong on any quadrant because 0 is not positive or negative, not plus or minus. So, the ordered pair 0, 10 does not belong on any quadrant. The origin 0, 0 does not belong on a quadrant. The ordered pair 0, negative 8 does not belong on any quadrant. And the ordered pair negative 8, 0 also does not belong on a quadrant because they're all 0, and 0 is not positive or negative, and the not positive or negative definition is not plus or minus. But all of these have a plus or a minus, but 0 doesn't have a plus or a minus because it's not positive or negative. So, if an ordered pair rests on the lines, or on the middle in the origin, in which case, then they do not belong on a quadrant. Because, look at this. 0, 2 does not belong on a quadrant, but it does belong between quadrants 1 and 2. Because 2 is a positive number on the y-coordinate, but 0 is not positive or negative. So it doesn't belong on a quadrant, but it belongs between the quadrants. So, quadrants 2 and 1 are the quadrants it faces, but it does not belong on quadrants 2 or 1. It belongs in between. That is the only region where they belong. So, ordered pairs with their x-coordinate 0, their y-coordinate 0, or both of their coordinates as 0, do not belong on a quadrant at all. Like, for example, the ordered pair 6, 0 does not belong on a quadrant because, once again, there's a 0. 0 is not positive or negative, so it cannot belong on a quadrant. It only belongs on the lines. Yes, any ordered pair that does not belong on a quadrant only belongs on the number lines. It cannot belong anywhere else because there's pretty much nowhere else other than the lines and the quadrants that are there existing on the coordinate plane. So, these are the only two options you could take. If one or both of an ordered pair's coordinates are 0, they cannot belong in a quadrant because 0 is not positive or negative, not plus or minus, so it can't belong on any of those quadrants. But if both of their coordinates are not 0, then they belong on a specific quadrant because they are not 0. So they should belong on a quadrant if they're not 0. But if they are 0, they cannot belong on a quadrant because 0 is not positive or negative, as I mentioned several times already. So, 6, 0 does not belong on a quadrant. Negative 8, 0 does not belong on a quadrant. 0, 3 does not belong on a quadrant. So, if an ordered pair has a 0 or two zeros in it, then it cannot belong on a quadrant. So you see, any ordered pair that has a 0 as one of their coordinates, or both, in the origin's case, 0, 0, they cannot belong on a quadrant. If they don't have a 0, then they can belong in a specific quadrant, as long as they match for specific rules. Quadrant 1, x and y coordinates both have to be positive. Quadrant 2, x coordinate has to be negative, y coordinate has to be positive. Quadrant 3, both x and y coordinates have to be negative. And quadrant 4, x coordinate positive, y coordinate negative. So you see, positive positive for quadrant 1, negative positive for quadrant 2, negative negative for quadrant 3, and positive negative for quadrant 4. So that is the basics and the hard stuff about the coordinate plane. Now, since we know all of this, we can also interpret into everyday situations. We can even situate it as a cave cricket environment.
Cave crickets? Are they crickets?
Yeah, I think so. That's right, they are crickets. A typical cave cricket has up to a 2-inch long body and 4-inch long hind legs. 2 and 4. What do those numbers remind you of?
The coordinate plane!
That's right, Juliet. The numbers 2 and 4 are both positive numbers. And if we plot the ordered pair 2, 4, that belongs on a quadrant because they are not 0. They are positive numbers, 2 and 4. They're not 0, so they have to belong on one quadrant. So, it would belong in quadrant 1. You want to know why? Because 2 is positive and 4 is positive. So, the ordered pair 2, 4 belongs on quadrant 1 because 2 and 4 are both positive numbers. So you see, we can interpret as quadrants. We can also interpret it as a literal environment and graph the whole entire cave cricket cave environment just by using lines and graphing dots. This is the cave entrance. And that is a specific number, you guys. This number line counts by 2s. Where do you think the cave entrance is? Let's look very carefully here. We know it cannot be 10 because it's 1 more than 10. What is 1 more than 10? 11. That's right. 1 more than 10 is 11. So the x-coordinate is 11. So the cave entrance has 11 as its x-coordinate. But what about its y-coordinate? Let's look carefully here. It's between 8 and 10. What number is between 8 and 10? 9. That's right, Talking Baby Hippo. The y-coordinate is 9 because it's between 8 and 10. So the cave entrance is in quadrant 1 as well because they both belong on the same place on the coordinate plane. And plus, 11 and 9 are both positive numbers, so it must belong on quadrant 1. So although it doesn't look like 11 because there is no 11 shown, there is no 1 shown either because this counts by 2s, 2, 4, 6, 8, 10. However, the empty spaces between those numbers are the odd numbers. Look, between 0 and 2, there's 1. Between 6 and 8, there's 7. Between 8 and 10, there's 9. Between 10 and 12, which is not shown here, there is 11, which is on the very end. 11, 9 is where the cave entrance is. So, the cave entrance is 11 units to the right of 0 and 9 units above 0. Because 11 is positive, and so is 9. 11, 9, that's where the cave entrance is. Now, these ordered pairs, A, B, C, D, and E, show where the cave crickets live. This ordered pair right here belongs on quadrant 1, because look, this is 7, 6. 7 and 6 are both positive. This one too, because 3, 4, both of them are positive. But ordered pair C does not belong on any quadrant because it is 0, 1. Oh yeah, it has a 0 as its x-coordinate, so it cannot belong on a quadrant because it has 0 as one of its coordinates, and 0 is not positive or negative at all. So ordered pair C is pretty much 0, 1. Ordered pair D belongs in quadrant 3 because look, -5, -7. You see, we are doing this well. And ordered pair E is belonging in quadrant 3 as well because -10, -6. They're both negative. Quadrant 3. So, both E and D belong on quadrant 3. C does not belong on any quadrant, and A and B belong in quadrant 1, and the cave entrance. And technically the cave exit, if we count this as the exit, in which case it would theoretically be -11, -5 or something, or -11, -7, or there. So, that would be the cave exit because it's on quadrant 3. The cave entrance is above. So, we know that based on all this information we gathered, that ordered pairs A and B belong on quadrant 1, ordered pairs E and D belong on quadrant 3, and ordered pair C does not belong on any quadrant at all, because, look, it's 0. It sits on the number line, so that means one of the coordinates is 0. That is how we can interpret our daily lives into coordinate planes. We can't help it. Coordinate planes are all around us, and we do not even realize it. Here, let's visualize it as walking. If you walk backwards 2 times, 1, 2, that's a -2. 2 units away from 0, or where I am standing. 2 units away is -2. Guys, the coordinate plane is on the very ground you're stepping on, because you can represent distance by just walking. Look at this. If I walk backwards while I am facing down 2 times, then that is the ordered pair 0, 2. And although it does not look like a negative number, it's really not, because I'm really going up. I would be going like this. 1, 2. That is the ordered pair 0, 2. 2 units away from 0 and 0 itself. And now I'm going to do another one. 2, 1. Look, 2 units away from 0 and 1 unit above 0. That is the coordinate plane. The coordinate plane is the ground you're walking on, because look, let's do this again. On the x-axis, that is the horizontal line. 1, 2 units to the right of 0, where I was standing right now. And if I turn and move 1 up, that's 1 above 0. So that's 2, 1. I was in quadrant 1 when I stopped walking, because 2 and 1 are both positive numbers. And hey, quadrant 1 is in the coordinate plane. The coordinate plane is invisible, and you just do not realize it. It's magic. It's a magical experience. So if you want to try it for yourself, then try it. Try walking in a specific direction and see which quadrant you'll end up in. Like, -3, -3. Oh, I must be in quadrant 3, because -3 and -3 are both negative. So, I must have been in quadrant 3. That would have been like this. -3, -3. I walked -3 down and -3 left. So, that would be in quadrant 3, because -3 and -3 are both negative. So you see, it's right there. You just don't even realize it. This is the center. This is the center of the invisible plane. This is 0, 0. But when I move 3 units down, 1, 2, 3, that would be 0, -3, because I didn't go left or right before. But when I went left, it changed into -3, -3, because I went to the left 3 times. You see? The coordinate plane is there, on the ground. You just don't see it very easily because we don't really walk that way as often. But it is a great experiment to try if you want to learn more about this awesome coordinate plane. And the coordinate plane also does not stop there. We can also learn about rational numbers. A rational number is any number that can be expressed as a fraction a over b, where a and b are integers, and b is not equal to 0. So again, that 0 part. So the ordered pair 0, 1 cannot belong on a quadrant because it has 0 as one of your coordinates, which is not positive or negative. It is the same thing for rational numbers, because you cannot divide by 0. Remember, if b is equal to 0, then the rational number rule would violate its own rule because you can't divide by 0. That would be an error. Try dividing by 0 on a calculator, and you would get an error. Don't believe me? We are going to try this right now with a real built-in toy Minnie Mouse cash register calculator. I can prove it to you how division by 0 is impossible. Oh wait, there's no division. Never mind, it only shows plus or minus. It only shows plus, sorry. We'll do it on the other cash register. Yes, there we go. I was confused. Now, this will prove it to you how division by 0 is impossible. Let's do 6 divided by 0, and what do we get? Read that tiny word, that tiny little word up there. You know what that tiny word says? It says error. That says error. Error means it cannot figure out the solution to that problem because you divided by 0. Guys, you cannot divide by 0, which means b has to be either greater than or less than 0. It cannot be 0. So, b cannot be 0, but a can be 0. Because 0 divided by 6 is 0, but 6 divided by 0 is undefined. So, that's why b cannot be 0 for rational numbers. If b is 0, it is not a rational number at all. Irrational. Irrational numbers are numbers that are not rational. And anyway, we can also write the opposite of rational numbers. Like, the opposite of negative 2/3 is positive 2/3, because the opposite of negative is positive. But this is where things get tricky. There is a negative 3/5 on the parentheses, but there's also another negative sign outside the parentheses. That negative is not the negative sign. It's the opposite sign. This means that it is the opposite of negative 3/5. The opposite of a negative is a positive. So that's why the opposite of negative 3/5 would be a positive 3/5 instead of a negative 3/5. Because obviously they both cancel out, leaving it with a positive answer. So you have to watch out for those. And also, 1 3/4 is positive, but there's a negative outside the parentheses. This means the opposite of 1 3/4, which is negative 1 3/4. So, we can interpret that, but we also have to be very, very careful not to mess this up. And if we can figure out rational numbers, we can also find the absolute value of them. And we can compare them too. Negative 0.5 is greater than negative 1. Because if we look on the number line, let's look on the number line for a second. Where is negative 0.5 on the number line? It's here, right? Between negative 0.75 and negative 0.25. But where is negative 1? All the way here. Negative 1 is to the left, but negative 0.5, while also to the left, is more to the right than negative 1 is, because negative 0.5 is closer to 0 than negative 1 is. That is why negative 0.5 is greater than negative 1, although a positive 0.5 is less than a positive 1. You see, it's the opposite, just like our quadrants. And now, this is where things get tricky. I did this one completely wrong. 2/3 is not greater than 0.75, because if we look here for a second, 2/3 is right here, but 0.75 is slightly more to the right, which means it's slightly greater than 2/3. So 2/3 is less than 0.75, because 2/3 is 0.6 repeating, but 0.75 is greater because 0.75 has 7/10, but 0.6 repeating has 6/10, and 7 is greater than 6, so, and 6 is less than 7, so 2/3 is less than 0.75. But 0 is greater than negative 1/3, because negative 1/3 is to the left of 0, or less. So you see, negative 1/3 is less than 0. And all these other numbers. Now, the absolute value and the opposites can be a little bit trickier as we get to these ones, the absolute value ones. The absolute value of negative 0.5 is 0.5, and the absolute value of negative 0.75 is 0.75. And guess what? We can compare them from there. Where is positive 0.5? It's here. Positive 0.75 is here. Positive 0.75 is closer to 1 than positive 0.5 is. So, the absolute value of negative 0.5 is less than the absolute value of negative 0.75, although negative 0.5 is greater than negative 0.75. That's crazy. The absolute value changes everything. And we can also do the same with opposites. Negative 1 is less than 1, because negative 1 is a negative number, but 1 is positive. Negatives are always less than positives. And these other ones are where it gets very tricky. Look at this one. There is a negative outside the parentheses and a negative inside. Negative 0.5. The opposite of negative 0.5 is positive 0.5. So, negative 1/3 is less than the opposite of negative 0.5, because the opposite of negative 0.5 is positive 0.5, and 0.5 is here, but negative 1/3 is all the way here, which is to the left, or less. So, that's less than the opposite of negative 0.5. And if we look at these ones, these are more difficult because we have absolute value and an opposite. So, the absolute value of negative 2/3 is positive 2/3, but the opposite of positive 2/3 is negative 2/3. So, the opposite of the absolute value of negative 2/3 is the opposite of positive 2/3, which is negative 2/3. That may seem so confusing because these negative signs should cancel out. However, the only exception is when it's absolute value, because absolute value is positive, and the opposite of positive is negative. So, yes, the opposite of the absolute value of negative 2/3 is negative 2/3, because the absolute value of negative 2/3 is positive 2/3, and the opposite of that is negative 2/3. So you see, 2/3 is greater than negative 2/3, because 2/3 is positive, but negative 2/3 is negative. So that is where it gets the trickiest it could ever get. And let's do this one. Look at this one. The opposite of negative 0.25 is positive 0.25, and this is 1/4. Where do 0.25 and 1/4 rest? They both rest here. They both rest here. But they are both the same, which means they're equal. 1/4 is equal to the opposite of negative 0.25, because the opposite of negative 0.25 is 0.25. Exactly. And 1/4 is 0.25 in fraction form. So, that'll be 1/4 equals 0.25. That is what we are getting to. And if we can compare them, we can order them too. So if we are asked to write them from greatest to least, then we'll have to look at the number line to help us. Negative 0.25, negative 1, and negative 0.75 are all negative numbers, which means we only look to the left. We don't look at the right, because they're all negative numbers. But this is where the trickiness rises. Look at it. They are all numbers but 2 of them are decimals. But don't worry. Negative 0.25 is the greatest of them because negative 0.25 is the closest to 0, whereas negative 0.75 and negative 1 are the farthest away. This means that negative 0.75 is less than negative 0.25, but greater than negative 1. So, this is in order. Negative 0.25 is the greatest. Negative 0.75 is in the middle. And negative 1 is the least. Because as we go more to the left, we get lesser and lesser and lesser. That is the important part of this lesson. And also, from least to greatest, we could rule out all the negative numbers first. And then we could go to 0 and then all the positive numbers from there. So which number is the least? We'll have to figure that out. So, negative 1/3 is here, but negative 0.5 is all the way here, which means negative 0.5 is less than negative 1/3. Yes, so negative 0.5 would be the least. Negative 1/3 would be the second least, 0 would be in the middle, and 1/3 would be the greatest. Because 1/3 is a positive number, obviously. And how do we know that negative 0.5 is less than negative 1/3? That's because it's more to the left of 0 than negative 1/3 is. So in other words, negative 0.5 is less than negative 1/3 because negative 0.5 is farther away from 0 than negative 1/3 is. So that's why negative 0.5 is the least out of this order. And if that wasn't enough, check out this. Our whole entire world is a coordinate plane. What? Our world? Yes. There's no way that our world can be a coordinate plane. Well, Byron, turns out you're wrong. The world can be a coordinate plane if we look at all the 4 regions of Earth. Let's look at Earth. Earth is not quite a perfect sphere because of the rounded edges, which I will not explain fully. But I will explain the other part of Earth. When you look at Earth, it has all the parts. The land, the water, and the poles, the north and south poles. But what else do you notice? You can also split it into 4 equal fourths. Halves and fourths. So, all of the countries and the continents and the oceans and the lakes and the rivers and the ponds and whatever all belong on a specific quadrant. But specific parts don't. Like the origin, 0, 0, which is all the way here, doesn't belong on any quadrant. But Asia belongs on a quadrant. You know why Asia belongs on a quadrant? Because it rests here rather than here. So, it rests here. It rests in quadrant 1. You wanna know why? Because this way is positive, and this way is positive. Both of them are positive, which means Asia is in quadrant 1. But Australia is in quadrant 4, because positive, negative. Most of South America is in quadrant 3, because remember, negative, negative. The other part of South America is in quadrant 2, because remember, negative, positive. North America is in quadrant 2, because remember, negative, positive. You see where I'm going at, do you? Madagascar is in quadrant 4, because remember, positive, negative. All of those loose ends are tied together by our whole entire world, and even our universe with its stars. And if you look here, there are many lines. There are many invisible lines that people like to map out. The measure of latitude is the maximum number of degrees for the first coordinate. And the maximum number of degrees for the second coordinate is the measure of longitude. So, latitude and longitude. Latitude is like the x-axis, and longitude is like the y-axis, because, remember, first coordinate latitude is x-axis because first coordinate is on the x-axis, but the second coordinate is on the y-axis, so longitude must be on the y-axis. So, yes, that's how we can interpret latitude and longitude. It may be a bit harder because you see all these lines and I'm like, wait, does that go there? But eventually, you will get the hang of this new subject and you will feel that our whole entire world, our whole entire Mother Earth is a coordinate plane. Just look at it. Look at all the lines that connect together. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. That looks a lot like this. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. That looks a lot like that, too. So you see, this proves that our whole entire mother planet Earth is a coordinate plane, and that it has quadrants. Just like the ground, which I mentioned earlier. And if we flip over here, there is nothing else. We went to the whole entire book. We made it through the end of the book. Well done, everybody. This was a remarkable mathematical journey for all of us. And even I didn't think we could complete it, but we completed it anyway. Wow. Look at all of this stuff. It's very neat. You don't realize it, but math is existing right now. Even on the very ground you're stepping on. So, until next time, it's me signing off. Come back for more math adventures. And if you want to see more math videos relating to the subject or unrelating to the subject, check out our previous math videos. They are very informational and educational too. They also provide lots of entertainment, so make sure to watch them. Bye, guys! Bye!